We talk about clinical research on senolytic compounds that influence specific biological pathways that promote youthful cellular characteristics and encourage the body to manage senescent cells. With age increasing the risk of developing diseases, one of the therapeutic options is to interfere with the molecular and cellular pathways involved in age-related tissue dysfunction, which is in part caused by the accumulation of senescent cells. What is cellular senescence? Senescent cells are unique in that they eventually stop multiplying, but don't die off when they should. They instead remain and continue to release chemicals that can trigger inflammation. Like one rotten fruit in a fruit basket corrupts the entire basket, a relatively small number of senescent cells can persist and spread inflammation that can damage neighboring cells. Most types of senescence are largely triggered through the DNA damage response pathways, DDR. The change in DNA content following loss of telomeric length is recognized as damage, resulting in the initiation of the DDR response. When a cell divides, chromosomes are replicated and telomeres shorten in length with each cell division. Loss of telomeric length has been suggested to be the biomarker of choice in replicative senescence. Lifestyle choices such as smoking, diet, stress, and exercise can have an effect on telomere attrition. How cellular senescence affects the body. The number of senescent cells in a person's body increases with age. As the aging immune system becomes less efficient, senescent cells accumulate and taint healthy cells. This can affect a person's ability to withstand stress or illness, recuperate from injuries, and learn new things, since senescent cells in the brain can degrade cognitive functions. As a result, cellular senescence has been connected to a multitude of age-related conditions, including cancer, diabetes, osteoporosis, cardiovascular disease, stroke, Alzheimer's disease, and related dementias, and osteoarthritis. It has also been linked to declines in eyesight, mobility, and thinking ability. Investigations are underway to see if senescent skin cells may contribute to sagging and wrinkling, and if senescent cells might also be connected to the cytokine storm of inflammation that makes COVID-19 so deadly for older adults. In normal tissues, there is a balance between the generation of new cells via cell division and the loss of cells via cell death. Old cells become damaged over time and are eliminated. This is an essential form of renewal. Examples include shedding of skin cells and the replacement of the cells lining our digestive tract. Like cell division, cell death is also tightly controlled. Cells frequently die by a process termed programmed cell death, or apoptosis. Apoptosis is the cellular equivalent of a self-destruct button. Apoptosis is a very orderly process during which the genome of the cell is broken down, the cell is fragmented into smaller pieces, and the debris is consumed by nearby cells, phagocytes, that clean up the cell fragments. What are senolytic drugs? Senolytics are a class of drugs that selectively clear senescent cells. This is done by inducing apoptosis of senescent cells. The first senolytic drugs dasatinib, quercetin, fisetin, and navitoclax were discovered using a hypothesis-driven approach. The majority of candidate senolytic compounds are repurposed anti-cancer molecules, such as the chemotherapeutic drug dasatinib and the experimental small molecule navitoclax. Quercetin is a plant chemical, or flavonoid, that's found naturally in foods including apples, onions, teas, berries, and red wine and ginkgo biloba. Quercetin acts as an antioxidant, neutralizing free radicals, the chemical byproducts that harm cell membranes and damage DNA. It is available as a dietary supplement. Quercetin also possesses antihistamine, allergy-relieving, and anti-inflammatory properties. Fisetin is a flavonol belonging to a flavonoid widely distributed in fruits and vegetables, such as strawberries, apples, grapes, and cucumbers. It exhibits various activities, including neurotrophic, antioxidant, anti-inflammatory, and anti-angiogenic effects. Preclinical studies conducted have shown senolytics eliminate senescent cells, resulting in delaying, preventing, or alleviating multiple age and senescence-related conditions, including frailty, cataracts, age-related osteoporosis, age-related muscle loss, radiation-induced damage, cardiac dysfunction, vascular dysfunction and calcification, pulmonary fibrosis, hepatic steatosis, metabolic syndrome, diabetes, and dementia. In mice, administration of senolytic agents and elimination of senescent cells have shown to improve physical function and extend health span and lifespan. Further randomized, controlled clinical trials using different senolytics are underway or planned. The findings from these trials will not only determine the safety and efficacy of senolytics, but they could be transformative in the care and treatment of older adults and patients with multiple chronic diseases. Please subscribe to BodyWise channel for research-based health information.